Well, hello again. Today we're going to look at a basic review of subnetting and subnets in general, mainly for Microsoft testing. This is not going to go quite as in-depth as you might look at for Cisco certifications. This is mainly geared towards Microsoft stuff and the basics overall of what a subnet is there to do and then how to subnet for a number of hosts and a number of networks. This is going to be broken down into three parts. Part one, obviously, because you're looking at it now, is just going to be an overview of what subnetting is and basic IP addressing to make sure everybody's on the same page. Part two will be specifically looking at subnetting for a certain number of hosts, and part three will be subnetting for a specific number of networks. So, in what we're going to look at here is specifically how addresses are broken down, the purposes of the subnet mask, some of the default IP address ranges that exist, the purpose of subnetting, somewhat important all things considered, and then basic binary to decimal conversions so you can look at things and try to get an easy feel for them as much as possible. So first off, IP version 4 address breakdown. Hopefully you know this already, but IP version 4 addresses are 32-bit addresses broken up into 4 octets. Now each octet has a total of 8 bits in it, giving you 4 times 8, 32 bits total. Each octet can have a maximum value of 255, so if all of the bits are set to 1, which we'll look at later in the basic binary to decimal conversion, you'll see that equals a total of 255. And sort of trivial knowledge at this point in time, but there's over 4 billion available addresses for the IP version 4 address range. Now, the basic purpose of a subnet mask is to take your IP address and break it down into two main pieces of information, the network ID and the host ID. The network ID is what's going to define what network you're a part of, and everybody with the same network ID can talk to each other without the use of a gateway address. The host ID then specifies which host, which computer you are on that specific network. So whatever the subnet mask covers, essentially, is what your network ID is. Anything the subnet mask doesn't cover makes up the host ID. So, if we take a look at this, to give you a basic example, which would be a little bit easier. If we look at the IP address 192.168.105.210, now this is a basic Class C address. We'll take a look at the default classes here in a second. And a default Class C address has a subnet mask of 255.255.255.0. So if we look at this, we can actually see that everything that's covered by the subnet mask outlined here in red is the network ID, so 192.168.105. Anything not covered by the subnet mask, which would be this last octet highlighted in blue in the IP address, would give you the host ID in this case of 210. So the network ID again would be 192.168.105. The host ID would be number 210 on that network, which comprises the overall IP address. If we look at a slightly different one, just to again get a basic idea for it, the IP address 172.212.104.155, this is a Class B address space, so it actually has a default mask of 255.255.00. This, you can see now, the subnet mask is only covering the first 2 octets. So my network ID would be 172.212, whereas my host ID would be 104.155, which again comprises the overall IP address of whatever that is, machine, host, whatever you're looking at. So default address classes. Whenever you're looking at an IP address that hasn't been subnetted, it has a default address class. The 3 main classes that you normally deal with day-to-day stuff are Class A, B, and C. There are Class D addresses, there are Class E addresses, but Class D is specific for multicasting, which is outside the range of this topic, and Class E is classified as experimental and government address ranges, which again you don't normally use on your internal and external address spaces. But Class A, B, and C pretty much is free to use whatever you want, internally specifically, externally obviously with internet addresses they have to be given to you. So we first off look at a Class A address. Now, all the classes are defined by the number that's given in the first octet, so the first range address that you see in an IP. So in this case here, if that first octet is a 1 through a 126, that's a Class A address. The default Class A address subnet mask is 255.0.0.0. So in this case here, with an example IP address of 10.1.0.50, subnet mask of 255.0.0.0, your network ID again would be 10, because 10 is the only octet being covered up by the subnet mask. The host ID would be 1.0.50. Now, Class A address space gives you quite a few addresses on them, something like 12 million or something addresses per space, so you've got a lot to work with there. A Class B address space starts off with 128 and ends at 191. So anytime you see a 128 through a 191 in the first octet, this is a Class B address, which by default has a subnet mask of 255.255.0.0. So again, if we look at a basic example of this, just a random Class B address of 172.125.54.102, default mask of 255.255.0.0, actually gives us a network ID of 172.125 with a host ID of 54.102. Again, obviously all comprising the overall IPv4 address of that machine or host. Now, you might be wondering for a second here what happened to the 127, because Class A stops off at 126. Class B starts up at 128, so 127 is obviously missing in that range. And I'm sure you're very familiar with the loopback address for IPv4 being 127.0.0.1. What this basically means is that using IPv4, an entire address space, Class A specifically, was killed to allow you to have a loopback address. Probably wasn't a lot of forethought put into it, but it's the way it is, and you're just going to have to deal with it. Class C. This is the one that's most commonly used now. A lot of times you see this both in examples and internal networks that are relatively small. Class C is a very common one to deal with. And this one, first octet, starts out at a 192 and ends up at 223. Default Class C subnet mask of 255.255.255.0. So if I take a look at an IP address of 192.168.100.125 with a default mask of 255.255.255.0, we get a network ID of 192.168.100, because again that's what this subnet mask is covering, and a host ID of 125, giving me the overall IP address. Now, subnetting in general has a basic purpose. The main purpose of subnetting is to take a large network that has lots of hosts and break it down into smaller networks, either for management or just logical segregation of devices and hosts. So that's really the purpose of subnetting. There's also an option called supernetting, which is the exact opposite, and that is actually taking smaller networks and recombining them and making larger networks out of it. It's not done very often, especially on Microsoft testing, so we're not going to talk about it here, but it's basically the exact opposite of subnetting. Anybody that understands subnetting, really, supernetting is very simple. Now, when we take a look at basic binary to decimal conversion, now again, each octet in an IPv4 address has 8 total bits in it. Right? So 4 octets, again, 8 bits apiece, gives me 32 bits total. Now if I take a look at the 8 bits, now these would be 1, 2, 3, 4, 5, 6, 7, 8, the 8 bits in an individual octet, and these would be sitting here as all ones, we'll say, in terms of binary format. But when we look at them as decimal values, right, to get an idea of what they actually add up to in terms of a base 10 decimal representation, you'll see that the increments, when you start going from right to left, they just keep doubling. So it's a 1, 2, 4, 8, 16, 32, 64, 128. If you add all of these up, you get to 255. If you're only using certain bits to make your subnet mask, you would add up obviously whatever bits necessary to equal what you need, which we're going to take a look at here in a second when we actually look at some subnetting. Now, where these numbers come from, I don't normally write this down because a lot of people really don't like dealing with it, but it's exponents. So this is taking basically a base 2, so it'd be 2 to the 0, which would give you to 1, 2 to the 1, 2, 2 to the 2, which would 4, 2 to the 3, 8, 4, 16, 32, 64, 128, so on and so forth. Exponents is not something most people enjoy dealing with it, so I try to leave it off. So, basic binary to decimal conversion, again looking at a basic subnet mask, a class B subnet mask specifically of 255.255.0.0. The subnet mask, you'll notice, is a big, long, contiguous string of ones. And when we start looking at subnetting, you're going to notice this specifically, that the subnet mask is always a big, long, contiguous string of ones from the left to the right. You'll never have a 0 just randomly in the middle of a subnet mask, or else it's just wrong. Something you've done is incorrect. And when we start subnetting, what we're actually doing is extending this string of ones and adding new bits to the subnet mask and taking away bits from my hosts to allow me to break down the network. But right now we look at this standard class B subnet mask. I've got 8 bits here, all ones, so 16 bits total, and then the rest being zeros, so it'd be 255.255.0.0. Alright, now that was a really quick and dirty way of giving you a basic breakdown of what the subnet mask is there to do and a real basic conversion of binary to decimal. We're going to take a look at a little bit more of this in the next option, part 2, which we start looking at subnetting for a specific number of hosts. So feel free to review this if you need to, come back to it if there's something you're kind of missing when we start looking at the next two, and I'll see you in a second.